Good morning all. I am Radhe Shyam Panda. I'm working as an assistant professor in AI&ML department, CMR Engineering College. And today we are going to discuss the backtracking algorithm with a classical example of that is graph coloring problem. In backtracking algorithm, what happens? We explore all possible solutions by traversing a particular path of the tree, and whenever we feel that this is leading toward the dead end, we'll backtrack. So this graph coloring problem is one of the classical problem of the backtracking algorithm, where we have been given a graph and we have been given certain limited colors, and we need to check whether we can color those graph by keeping some constraint in view, like no adjacent node of a graph should be colored in a same color. So for that, there's a graph given to you, and you can see here there are 5 nodes in this graph, and we have been given a color, like the number of colors are 3, and we are assuming that the colors are red, green and blue. I need to color this graph in such a way that no adjacent node will have same color. Let us try to do this by, suppose I am giving a red color to this node. I cannot give red color to this node or this node because these are the adjacent node of this node. So I can give green color here, or I can give blue color here. Let's say I am giving green color. So here the adjacent node is having red color, the second node is having green color. Now let us try to color the third node. In third node, since one of its adjacent node is having color green, I cannot provide green color to this. So can I give red color? Let us try. Yes, I can give red color, because for this node, if you see, all its adjacents are either having other than red color or not having any color. Let us move toward the fourth node. In fourth node, the adjacent node of the fourth node are third node and fifth node. Third node is having red color, fifth node is not having any color. So I can give, like, other than red color, I can give any color. So I am providing green color again. Can I give green color? Yes, I can give green color. Now come to this fifth vertex. In fifth vertex, one of its adjacent color is red, another is green, other is red, another is green. So only I can give the color that is left is blue color. So I can provide blue color here. So in this way, if you look into this graph, all the vertices are given color, but no adjacent vertices are having same color. So this is the one of the solution of this problem. Whatever I have done through my natural intelligence, now that will be done through the program. Here n is equal to 5 means I am having a graph with 5 nodes. M is 3, it means I am having 3 color only. Now I will be trying to implement this whole concept in a algorithmic way. Now for this graph, I have converted this graph into adjacency matrix so that we can provide the input to our algorithm. Now this is the graphical representation of the graph, and this is the mathematical representation of the graph. The same graph can be converted into adjacency matrix. Now this will be acting as the input to our algorithm. Initially we'll be assuming that there is a global array called X, and X, the length of the X is 5. Why it is 5? Because we are having 5 nodes. Therefore, let us try to color the node number K. This K can be 1, 2, 3, 4, 5. Okay. Now, if I try to color it, first I am using do while loop. Do while loop because I need to check the color, whether which color will be appropriate for a particular node, and then that thing will be repeatedly done. That is why a loop is here. Now I am trying to get the color for the kth node, and that color will be stored in this array. Initially, since this X array is a global array, so initially value will be 0. This is the property of the global variable in the program, that if you are using a global thing, so initial value, the default value for the global storage is 0. Now I am trying to get a color for this kth node, and this function, this method is responsible to provide me an appropriate color. Now, I am assuming that this algorithm will provide me the appropriate color. That color will be stored in this xk. Now I am checking if xk is equal to 0, means I am not getting any color. I am not getting any appropriate color so that the graph can be colored. So if I am not getting any color, it is returning. I'm coming out of this algorithm. Now, if that k is equal to n, if this condition will not work, control will come here, and if k is equal to n means I have checked all the vertices, then I will be writing the solution that is stored in the X array from 1 to n. Here in all these positions the color will be stored, and that color will be printed at the end of this algorithm. Otherwise, if this condition is not getting satisfied, it will come to the else part, and I will be trying to fetch the color for the k plus 1th node. Okay, so for the next node I will be getting the color, and in this way this whole algorithm will work, and eventually we will be getting all the colors for all the nodes. Now the question arises, since I was assuming that this is picking me the this is getting me the appropriate color, so how this function will work? Now come here, I am passing kth node to get node color. Here again I am using do while loop, because repeatedly I need to fetch, I need to check the first I have to find out the color, then I'll check whether that color is appropriate to be filled at that particular vertex or not. So this formula will be working here. So this formula is under this do while loop, so it will be repeatedly executing. Now look here, xk, initially the value of the xk is 0, 0 plus 1, that is 1, mod m we are having 3 colors, so the value of the m will be 3, 3 plus 1, that is 4, 1 modulus 4, it will be producing 1. So here in xk, what value will be coming? 1. Now it is giving me the suggestion that for the first node I can provide color number 1. My color number 1 is red color, I can get that. Now I am checking. After that, once this value I have fetched, I will be checking this condition, xk equal to 0. No, in our case, since we are having 1, so this condition is false. Now I am coming to this for loop to check whether any adjacent node of this first node is having this red color or not. So for that I am using this matrix, the cell of this matrix gkj. K is my right now the value of the k is 1, and since this is the beginning of this for loop, so j is also 1. So in this way, for this particular cell, I will be checking whether this particular cell is the adjacent of our node, or if it is adjacent, whether the color of the kth node and jth node are same or not. If they are same, so this loop will be broken, and ultimately at the after the execution of this loop, what will be happening? It will clearly suggesting me whether I can give that color or not. After the smooth conduction of this for loop, if it is not breaked anywhere, it will smoothly come to the 8th statement, where I will check what is the value of the j. If the j value is n plus 1, then it will be returning the appropriate color. That color will be stored here, and that color will be finalized. And this will keep on happening repeatedly, and eventually what will be happening? All the colors will be stored in this array, and that will be our solution. Thank you.